She'll probably be more in love with it than us.
Alright, so we're going to start with Unit 10. Unit 10 is on 3D geometry, so we're going to go from doing what we've done so far, which is pretty much all two-dimensional shapes, to moving up to three-dimensional shapes. So the good news is we're taking a break and leaving like trig behind for a little while, so SOHCAHTOA and all the properties of triangles. And we're going to move into a unit that is probably sort of what you expected to do in geometry, so area, volume, surface area, that type of stuff, where it's stuff that you've seen before probably. And it's a lot of, I don't want to promise that, but it's not the focus. There's a lot of formulas, but it's a lot, like you'll have all the formulas, so it's a lot of plugging in and figuring out. All right, so every three-dimensional figure is composed of faces, edges, and vertices. So a face is just the side of the figure. So for instance, a lot of times we picture a shoebox. There are 6 faces of a shoebox. There's the top, the bottom, the side, the front, and the back. So those are all faces. And then more specifically, a base is just going to be your top and your bottom. So a base is a face, but it's the top and bottom. All right? So in a prism has 2 parallel congruent polygonal faces. So that just means shapes, like polygons. The faces are polygons, okay? So for instance, this would be called a triangular prism because it has a base and a base that are 2 congruent triangles. So it's a triangular prism, okay? This is called a cylinder, which is formed by 2 parallel congruent circular bases and then a curved surface that connects them. So how many faces does a cylinder have? 2. Just 2, all right? What about a triangular prism? How many faces does that have? 5. What are they? The top, the bottom, and then there's 3 sides that would form a triangle, right? Okay, a pyramid is 1 polygon base, and then it all meets at the same common vertex. So we would call this a triangular pyramid because it has a triangle as a base, and then it meets at a common vertex. Are you okay? Do you need some water? No? Okay, just let me know if you do. All right, and then a cone is formed by a circular base with a curved surface that connects to 1 vertex. So essentially, a cylinder is similar to a prism, except that its bases are circles, and a cone is similar to a pyramid, except that its base is a circle. All right, so here are some common pyramids and prisms that we look at. And again, what's the difference between a pyramid and a prism? A pyramid has 1 base, and then all of the edges line up with a vertex at the top, whereas a prism has 2 congruent bases. So the top and the bottom look the same, and then it has faces that connect all the sides. So this is a triangular prism because it has a triangle base, a rectangular prism because it has a rectangle base, a pentagonal prism because it's a pentagon at the top and bottom, and then a hexagonal prism because it's a hexagon at the top and bottom. Same thing for all those pyramids down there. The base is a triangle, a rectangle, a pentagon, or a hexagon, but then it meets up at a common vertex. Could you have an octagonal prism? Yes. Could you have a nonagonal prism? Yes. Could you have a 14agonal prism? Yes. It would just be 14-sided bases, and then all the faces would connect it. All right, so we classify 3-dimensional figures using their vertices, their edges, and their bases. So for a second, before we do that with these 2, let's talk about what those words mean. So vertices, what's a vertex? It's like the point where things connect, right? So for example, in this triangular prism, how many vertices would this have?
5, 6.
Here would be 1, 2, 3, 4, 5, 6. So there'd be 6 vertices there. All right, edges. What's an edge? The lines you would have to draw to connect them. So how many edges would this have?
3.
Would have 3 on top, and then 3 on the bottom, and then 3 connecting those. So it would have 9 edges, and then how many faces? 5 faces. Okay. What about a triangular pyramid? How many vertices would this have? 4. It has 3 vertices on the base, and then they all go to a common one at the top. How many edges would it have?
6.
And then how many faces?
4.
So there'd be the base and then the three sides. Okay? So all of those, this is how we classify all of these. So you need to be able to name how many vertices, how many edges, and how many faces any of these figures have. So this first one here, first of all, name this. What is it? Is it a prism or a pyramid?
Pyramid.
It's a pyramid, and then what does the base look like?
It's a square.
It's a square, maybe rectangle, so it would be a rectangular pyramid or a square pyramid, depending on what that is. Okay, so this is a rectangular pyramid.
So you just find the shape of the base.
Find the shape of the base.
Add LAR.
Yep,
Basically.
and then it's either a pyramid or a prism. Unless it's a cylinder or a cone. Those are the only two that are different, and that's if it circles. Okay, so then how many vertices does this have? 5. How many edges? It has 5 vertices because there's one here, and then 1, 2, 3, 4. Why are there 8 edges? 4 on the bottom, and then 4 connecting to the top. Okay, what about faces? 5. The base, and then the 4 sides of the pyramid. Good. Okay, what is B? Cylinder. How many vertices does this have? 0. How many edges?
0.
How many faces?
2.
Good. Okay. Why are there no vertices?
Because there's no right points.
There's no corners, right? A cylinder has no corners, and the same reason there's no edges. There's no edges because there aren't any straight lines that make up a cylinder. The only thing it has is 2 faces because it has a top and a bottom.
If you don't have an edge, you don't have vertices.
Yeah, yes. If there's no edges, there can't be vertices and vice versa. That's a lie. Because that's a bad cone. A cone has no edges, but it has one vertex. All right. So there's a vertex up here at the top, but there's no edges.
Wait,
So you don't have
wouldn't
vertices.
those 2 be edges?
No, because I'm drawing those as straight lines, but imagine what it actually is. It's a round, like picture an ice cream cone. There's no edges. Yeah. So the way that you draw it, it looks like there's 2 lines, but there's not actually. Like if you picture an ice cream cone, there aren't actually lines. Okay, so a net is just a diagram of the surfaces of a 3-dimensional figure. So again, a net is a diagram of those surfaces. Basically what a net is if you took a 3-dimensional figure and cut it up and unfolded it, that's what it would look like. So this right here would make a cube, because if you folded up this side, folded these 2 sides in, and folded this one up and over, then this would form a cube. Okay? How can you tell that by looking at it that it makes a cube? Like, what's your indicator right away that it's going to be a cube? All the sides are equal. It's squares, so they have to make something that has all equal sides, which is going to be a cube. All right? A cube is another word for a square prism. All right, so what do you think this net would make if you folded it up? Do you need to go back? Or, okay, what would it make? A triangular prism. Why?
You see the bottom and the sides?
How do you know that? Well, how many bases does it have?
1.
It has 2 congruent bases, because here's a base and here's a base. It can either have 1 base, which would make it a pyramid, or it can have 2 bases, which makes it a prism. So it's one of those. Since this has 2 bases, it's got to be a prism, and the bases are what shape? Triangles, so it's a
I
triangular
would always
prism.
get confused with those. I don't know why.
Pyramid, 1 base, prism, 2 bases. There's not really any other option. I think what people get confused by is they want to think this is a base,
Yeah, that's what I
because you think like, oh, if I fold this, that will be on the bottom. That's true, but think about it like you can either have 1 or 2 bases. So since there's 3 rectangles, it can't be a base.
Oh, okay.
All right. So like over here, which one is the base, the triangle or the square? It has to be the square because there's how many triangles?
1.
So how many triangles? 4 triangles. You can't have 4 bases. So then this is the base, which makes it a square what?
Pyramid.
Good. It's a square pyramid because there's only 1 base. All right. So if you have trouble, because I always have trouble too. I'm not good at visualizing, like taking things from flat and turning them 3-dimensional in my head. So if you're not good at visualizing that, just think about either 2 bases or 1 base. If it's 2 bases, prism, one base pyramid.
Like those pictures?
Huh?
Is it just triangle ones or is there other ones?
No, you could have like, this could be, let's see. This is gonna look awful, I'm sorry.
Oh yeah, I remember that one.
And this would be a pentagonal prism because the bases are pentagons. So here's a base, here's a base. These can't be bases because there's 5 of them, okay? The only time this gets a little confusing is when they're rectangular bases, but then it's either gonna look like this or like this, okay? So just look out for your bases. Okay, a cross section is if you were to take a slice through something, then what would that slice look like? So the way that I always picture this, I don't know why, maybe just because I like cheese, but if every 3-dimensional figure were a block of cheese, if you were gonna slice that cheese, what would it look like? And with a cross section of prism, every slice will look the same, whereas a pyramid, what would happen? The slices would get either smaller or bigger depending on which way you sliced it, okay? So when you're doing a cross section, the shape is the green prism here. The blue is just illustrating like what the slice would be. So in a rectangular prism, every slice would look like what?
The rectangle.
This rectangle. It would look just like the base. Okay? Whereas if you had a square pyramid, every slice would look like a square, but it would get what? Smaller as you cut up. Okay, or smaller or bigger as you cut down. So in this cross section, what would every slice look like in this cross section? A triangle. And is it a prism or a pyramid? A pyramid, so are your slices going to get bigger or stay the same? Bigger, smaller, they will not stay the same. Okay, what about here? What is this? They're going to stay the same because it's a cylinder, and the cross section would be what shape? Circle, exactly. So a cross section is going to be a 2-dimensional shape. Okay? Questions on any of that? That's cross sections, 2-dimensional figures or 3-dimensional figures. Okay.